All right, this video is about what happens to a function when you change the parameters. So we've seen this by all kinds of different functions. So here's an example of what happens to a parabola. So if you have the parameter a, which means that you are multiplying the function, let's put times there so we remember, you are multiplying the function by a value. It causes the function to dilate, would be the word we would use from geometry, but it causes it to stretch or shrink vertically. So it's causing it to get higher, higher, higher. Those y values are higher than they would be normally, or the y values are lower, but by a factor. They're multiplied. So it's not shifted up, it's actually changing shape and going higher or lower. If it's negative, it causes it to reflect over the x-axis because, again, it's changing the y values. And again, the value, the absolute value, tells you whether it's stretching or shrinking vertically. The default for a, if you don't see it, is 1. You multiply something by 1 to have it stay the same. Let's do h next. So h is the parameter that you are adding or subtracting to the argument. So you are changing the argument by a value of h. So now you're not multiplying, you're adding or subtracting, and that causes a shift. The shape does not change. It causes it to move over. H is, again, being subtracted. So you're doing the value of the original x value minus h. So if you're subtracting 5 from the x value, that means instead of the 0.00, you don't hit the 0.0 until you don't hit the value of 0 until you're at 0.5 because you've moved over by 5. The typical value of h when it's not there is 0 because subtracting 0 does nothing to the original value of the function. The last one is k. K causes it to move up or down. It's a little bit of an optical illusion right here. Let's see, let's make it exactly 2. It kind of looks like maybe it's closer together up here. However, the distance, not the thing I want, the distance here is from 0 to 2 is 2 points. And the distance here, from here to here, you can see is also still 2. So it might look like they're closer together here. But the distance between, if you just go straight up along the grid, the distance between x and y continues to stay at a distance of 2. It just sometimes, as an optical illusion, looks like they're getting closer together, but they are not getting closer together. They're always exactly 2 units apart because the k value causes the graph to shift up by 2. Just like h, if there is no k value, it is 0 because adding 0 does nothing to affect the graph.